Quadratic Functions Part 2. In this video, you'll learn how to create quadratic functions and graphs that represent a situation. You'll also learn how to relate the vertex of a graph and the zeros of a function to a situation. And finally, you'll also learn how to determine the domain of a quadratic function. The vertex of a quadratic function is the highest or lowest point on its graph. The zero or root of a quadratic function is a point where the function is equal to 0. And the domain of a quadratic function is the set of input values that make sense for the situation. So if we have this graph, we can see that the highest point is our vertex. The points where our y value is equal to 0 are our roots. And the domain are all of the input values that are in our graph. So in this case, since the arrows are on the bottom and it goes on forever, it will eventually hit all of our x values. So the domain will be all values from negative infinity to positive infinity. Now let's look at some examples. A person with a t-shirt launcher is in the center of the stadium. He is holding the launcher 5 feet above the ground. The launcher sends a t-shirt straight up with a velocity of 90 feet per second. Imagine that there is no gravity and that the t-shirt continues to travel upward with the same velocity. We'll use this situation to fill out the table where we're given the number of seconds and we have to find the distance. At 0 seconds, the distance is just 5 feet since that's where the launcher is above the ground. After 1 second, we'll multiply it by the velocity of 90 feet and then add the distance of 5. So for 1 second, the distance would be 95 feet. And at 2 seconds, we'll multiply 2 times 90, giving us 180, and then adding the 5 gives us 185. For 3 seconds, we'll multiply that by 90, giving us 270, and then we'll add the 5 feet where the launcher started. Now at 4 seconds, we'll multiply that by 90, giving us 360, and then adding the 5 gives us 365. For t seconds, we're just going to write an expression that would give us a distance for any t value. So to find the distance, we'll multiply the velocity of 90 by t and then add 5 to it. Here's another example. The function defined by d equals 50 plus 312t minus 16t squared gives the height and feet of a cannonball t seconds after the ball leaves the cannon. So let's bring down the function they gave us and try to analyze each part. The 50 represents our initial height. The 312t represents our initial velocity. And then the 16t squared represents gravity, since this is subtracting and gravity always pulls the object down. Here's a graph of this function, so we're going to analyze what this graph means. We can see that the cannonball's height increases at first and then it decreases after it reaches its peak. We can see the highest point the cannonball reached was here. So this tells us the cannonball reaches 1,500 feet at 10 seconds. If we look at the x-intercept, or the root of the function, this will tell us the ball hits the ground after 19 seconds. Now let's look at another one. The height of a baseball is modeled by a function h given by the equation h of t is equal to 3 plus 60t minus 16t squared. The graph of the function is shown. So we can see the x-axis represents the time in seconds and the y-axis represents the height in feet. About when does the baseball reach its maximum height? The vertex will always show us our highest or lowest point, so this shows us our maximum. Since they want to know when it happens, we'll look at the x-axis at the time in seconds. So we can see this happens right before 2 seconds. About how high is the maximum height of the baseball? So we'll still use our vertex, but now we'll look at the y-axis since we're talking about the height. So the highest it reaches is about 60 feet. Now, when does the ball hit the ground? We'll look at the x-intercept for this value, and we can see it hits the ground right before 4 seconds. Now let's summarize what we've learned. Quadratic functions create parabolas whose key features include the vertex and roots. The vertex represents the maximum or minimum value of the function, and the roots of a quadratic represent the x values when the value of the function is 0.